Hi there, this is Math 7, Unit 3, Lesson 7, talking today about exploring the area of a circle. So we're going to investigate the areas of circles today. And so again, when we're talking about area, we're talking about the space inside, or this amount of space that covers up a portion of an object there. You can think like maybe like a floor, or maybe the amount of rug or a carpet that would cover a floor, or tiles that cover a bathroom floor, or something like that. What we're really talking about is how many, in this case here, we're going to be looking at really how many squares, for example, can cover up a circle of a certain size or certain radius or certain diameter. Okay, so we're talking today about area, and those are the things that we put to cover on top of something to cover something up. And that's what we're going to be talking about in this lesson today. We'll look next time at the idea of pi, but we'll get there tomorrow. Okay, so first of all, you began with estimating areas of circles. And in this first activity, you were given a sheet of paper that looked maybe something like this. And you had some different squares of some sort, circles on a grid. And you were asked to find the diameter of the circle and then to estimate the area. So if I begin first of all with the smaller one here, the diameter across this circle right here is going to be 1, 2, 3 for a diameter there. And so I can put that over here in my notes that the diameter is 3. And in terms of the estimated area, how many squares cover that shape right there? Well, I could look at this shape and think, well, I definitely have 1, 2, 3, 4, and 5 that would cover it no problem. But I also have these extra parts over here, right? I have these other little parts that are almost full. If you look at them, if a triangle was to cut across here, I could cut that in half and have almost a half triangle, a half a triangle, and half a triangle, almost, right? So really, I could say I have 5, and those half become another one, so that becomes 6. There's my 6th one, and these halves become my 7th one. So I might say I have approximately 7 squares that would be able to cover this circle here if I took the squares and cut them up to make them work there. So that's my estimated area for a diameter of 3. My other shape here, looking across the middle, I was at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 across there. And so my diameter was 12. And again, in terms of the number of squares that this would cover, I mean, I've got a lot here, right? Here's a big block right there. I can just kind of count that up first of all. So I'd have this block that's going to cover. That's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 6. So this is 60 right here already. I have another chunk right here. Here's another row of 1, 2, 3, 4, 5, 6, 7, 8 there. So that becomes 68 down here as well. So now I'm at 68, I'll be at 76. Okay, 76 plus another chunk here. This one has 1, 2, 3, 4, 5, 6. So we're at 82 plus another 6. It's going to put me at 88. 88. I have a couple up here. Let's go ahead and add them. 88, 89, 90, and then 92 there. Okay, so far I'm sitting at about 92. Oh, let's add some more here. Here's 92, 94, and 96, okay? So with those ones that I can see as being full squares, I'm already at 96. And am I done estimating? Probably not. I should probably continue kind of taking a look at what I have here, and hopefully this with your partner. You recognize that these are pretty much full ones right here, right? So I have some ones that are pretty full. I mean, these are almost whole squares right there in terms of those guys right there. And that's 4 of those. There's another 1, 2, 3, and then 4, and then here's another 1, 2, 3, and 4, and 1, 2, 3, and 4. So that's going to be another 16 almost full ones there. Again, just estimating, that puts me at about 9, 10, 11, about 112. So that's a little large perhaps what this could be, because those aren't completely full as we can tell, and I don't have a lot of smaller spaces to fill in with the gaps. Okay, a good estimate for this one, at least what I'm looking at here in my notes, says about 108 would be about a good estimate. Again, the idea is you're looking and thinking how many squares of one unit can fit inside of a circle that has that has a radius of 12. And so we would say probably about 108. Okay, just as an estimate there to do that. You might with some partners, if you complete this here, you might have some other numbers here. And so if I add a couple more numbers, one is a 7 and a 38. And another number that you might have on there, just a little bit bigger one, would be a 20 and a 312. So depending on your partners and what you have. Your next task was to plot those values from the table onto a coordinate plane. And that's why I added a couple points there as well. So when I take 3 is over here, and I'm at 3 and 7, I can see that I'm counting up by tens, 10, 20, 30, 40, 50, yep. So 3, 7 is going to be right about here, pretty low down there. There's 3, 7. All right, check. My 738 is here, and 38 is going to go 10, 20, 38. So it's going to be about here for 738. I got 12, and that's at 108. So that's 50 is here, and 100 is here. And so 108 might be about there. There's that guy. And then 20 is here, and we're going to go all the way up to 312. So this is my 300 line, and my 20 line, and that's 10, a little bit more, so we're about here for 20 and 312. Okay, so those are my 4 points there when I'm looking at the diameter of the circle compared to the area of the circle. And when we look at this, we've talked before about the diameter and the radius and circumference, and with those things we ended up being able to draw somewhat of a straight line from the origin, and that straight line allowed us to see that it was proportional. When we look at this one here, what we notice is that this seems to go more like that. It's more of a curve, isn't it? As we graph this out, it's more of a curve shape. So it's not quite the same. They do both increase. The diameter, as the diameter increases, the area increases. That was true with circumference as well. As the diameter increased, the circumference increased as well. But what's different though is that as the diameter increases, the area seems to go up much faster than what a circumference would do. It's also not going up in a proportional way. And that's a key thing here to look at, is that this is not a proportional relationship between diameter and the area. There is a constant increase. As one increases, the other one increases, but it's not increasing in a proportional way. And that's a key takeaway from this lesson today, okay? That it's not increasing proportionally, but it is increasing. Okay, so when we take a look then at 7.3 down here, move this a little bit. 7.3. We're covering a circle. It says here is a square whose side length is the same as the radius of a circle. So this length matches this length. We can call it 1 if you wanted to. Okay, it's 1 unit. Just making that up. All right, 1 unit. How many of the squares do you think it would take to cover the circle exactly? So if we take this square here, for example, and if we were to replicate it like so, and maybe cross it off like this, and then bring that to there, and bring that to there. We could look at this and think, well, if I was to actually copy that square over, it would take me 4 squares to cover it exactly, right? So 4 covers completely. But I also have a little extra there, don't I, right? So 4 would cover, but I have these extra pieces that I didn't actually need, okay? 2 definitely wouldn't cover it, okay? I can't do 2. 2's not going to make it work. If I had 2, I'm only going to be able to put it in little bits there, right? So 2 is not enough. 4 definitely covers. So the question would be, what happens with 3? You see, when you take this here, if I was to take those pieces there and chop them off, okay, and I have a little piece like this, right, and I have another little piece like this on the back side, right, flip that one over there, and I have these other pieces here, really these can almost go away, and I can actually almost reduce this down to just being able to do it with 3, potentially. It's pretty close, right? 3 looks more like a maybe. I could probably cover the whole thing with 3 and maybe a little bit more, right? And so what we look at when we look at this picture, we recognize that two squares wouldn't cover it. 4 is going to be a little too much. 3 gets pretty close, right? So what if you had like 3.5? Would that cover it? we'd probably say yes, that would definitely cover it. If I had 3.5 squares, I could definitely cover that space there. Okay, and that's just like the idea what we're looking at there, is that when we take a look at this square with a length of 1 and make that our radius, it takes about one of those, and takes about, 3 and a little bit more of those squares to cover up one circle. That's kind of the idea. Okay, what if I had a radius of 4? If the radius was 4 instead of 1, then this process, it's going to grow a little bit, right? It's going to be a lot bigger of a circle, and I'm going to have more squares. If the radius was 4, again, think about a square here. If the square has a length of 4, the area of the square is 4 times 4, and that becomes 16. But what we said before is that I can take 3 of those to fit into one circle. So if now my size was a 4, I take my area and I multiply that by about 3, and that's going to tell me that it'll take about 48 squares to cover a circle with a radius of 4. Okay, so up here we had a radius was 1, right? We said our radius was 1, and when our radius was 1, we took our area of that square, 1 times 1, which was 1, and we multiplied it by 3, and that said, it took about 3 circles to cover it. What if the the radius was 10? What would we do? If the radius was 10, again, we could take a look at what would the area of those squares be. It'd be about 100, and we multiply that by about 3, and that would tell us that it would take about 300 squares to cover a circle with a radius of 10. Okay, just a little activity there to take a look at. And so before we move on to the next thing, I'm going to show you just a quick little video from our book. Okay, and so a quick little video from our book here, and this video is just showing you that if you take a square, you can take a square here, and we can take 3 squares, and using stop motion we can show you how that these 3 squares can actually fit inside of one circle. So we're cutting out the extra pieces, and we're going to slide them down over here. And yeah, it doesn't fit perfectly, so they cut them up a little bit, but keep little scraps. Put another one in and cut up the pieces. And we can see that, oh, look at that, we can make it pretty much fit. We can get 3 inside of there, no problem at all. And in fact, not only do we get 3 inside of there, but I need a little bit more to fill in those gaps, don't I? So I can definitely use 3 squares, no problem, but I'm gonna need a little bit more than 3 to fill in that space in order to cover up a circle with a unit of 1. Okay, so that's part of today's lesson there. Let's move on to your summary. And with your summary, we're going to add a little chart here that'll help you with your homework, okay? So it says the circumference of a circle, the circumference C of a circle is proportional to the diameter D, and we can write this as C equals pi D. So circumference is proportional to the diameter. Got it. We got that down, no problem there. But, however, the key thing here, the area of the circle, the area of a circle is not proportional to the diameter, or the radius for that matter there, okay? It's not proportional for area. The area of a circle with radius r is a little more than 3 times the area of a square with the side r, okay? So the area of a circle of radius r is approximately 3 times r squared, which is what we were looking at just a moment ago. We saw earlier that the circumference of a circle of radius r is 2 pi r. If you write C for circumference of a circle, this proportional relationship can be written C equals 2 pi r. So that's for circumference. For area, it says the area of a circle with radius r is approximately 3 r squared. Unlike the circumference, the area is not proportional to the radius because 3r squared cannot be written in the form kr, right? The 3 is, but that r squared messes everything up a little bit, doesn't it? Okay? And so here's kind of an idea. Let's say we took a look at a diameter of a circle, and then we had an area of a circle. Okay, make a little chart here like so. If the diameter of a circle is 2, then the area of the circle is going to be about 3.14. We'll talk more about that in our next lesson here. And that's because our radius is half a diameter, which is 1. So we take that 1 and we're going to use 3.14 as our multiplier here. Okay, we could use 3 like we talked about right up above, but we're going to just use 3.14 for now. Okay, so if I put that number in there and multiply by 3.14, I get that. Now if the diameter was 16, that would make my radius equal to 8, right? Okay, no problem. But 8 squared is 64, and 64 times that 3.14 number is going to be 200.96. What's interesting here is this. As I go from 2 to 6, I'm multiplying by 8. But to go from 3 to 200 or something is multiplying by 64. Well, what do 8 and 64 have in common? Well, 8 and 64, 8 times 64 is going to be, 8 times 8 is 64. 64 is 8 squared, isn't it? Okay, so let's take another one for example. Let's say I had a diameter of 4. If I had a diameter of 4, my radius would be 2, and so my area, in this case, multiplying by that 3.14, would be 7.065. Okay, but if I had a diameter of 20, my radius would be 10, and now my new length would be 314, new area would be 314. So to go from 4 to 20 is multiplying by 5, but 7 times something gets you 314. Well, it's actually 7 times 25 that gets you to 314. Again, why? Because 5 squared is the same as 25. So that's that radius squared bit, right? That's the r squared is how that works out. It's a squaring, sorry, messed it up a little bit, but that's a squaring process there. So diameter, radius, area, and that's a little bit from today's lesson. Let's take a look at your homework today and see what makes sense to you. Alright, so first of all, we have these charts, these graphs, and it says the x-axis of each group has the diameter of a circle in meters. Label the y-axis on each graph with the appropriate measurement of a circle, either radius, circumference, or area. Okay, so taking a look here. First of all, I have 2 that are in a straight line and 1 that curves. One thing we already know is that our area is not proportional, so it's going to cause a curve to occur. So that's the first one already. I can see that's the area. No problem. Now when I look for diameter compared to radius and circumference, okay, let's just take a look at a point here. If this is 2 and that's 1, so I'm at 2, 1 right there, the radius is half of the diameter. Well, is 1 half of 2? Sure it is. So this to me looks like it's going to be the radius one right there. Over here, when you get a number like, for example, let's see if we can get one on a line. Here's 2. When this radius is 2, we're somewhere over here a little bit more than 6, right? So a little bigger than 6. Well, remember our equation for that was that circumference equals pi times the diameter. So if my diameter was going to be 2, then 2 times about 3 is a little more than 6. That puts it right about there. So this would be what I would use for my circumference in that case right there. Number 2 says here's a picture of 2 squares and a circle. Use the picture to explain why the area of this circle is more than 2 square units but less than 4 square units. This is just like the activity we did in class, right? When I take a look at this, the circle is going to be less than 4. It's less than 4 because I have this white space right there, right? That white space says I don't need 4 full squares to cover up that circle. But at the same time, what I can tell is that I'm going to need more than 2 squares to cover it up for sure. Okay? So what you want to do is you want to use some words to talk about why this is so. Why is it going to be more than 2 but less than 4? Again, we're kind of aiming for why is it somewhere around 3 in order to fill that up. What I looked at here is when I looked at these shapes, I have half a triangle, I have a triangle and a triangle which make a square. So this becomes square number 1 if I put those back together. This becomes square number 2 when I put that back together. And then I have these other parts here, right? There's half a triangle. If I was to put this guy over there, I could again probably fill that shape up pretty close, and I could add that over there and probably fill it up pretty close and have at least, you know, a full or another half and another half there, and maybe be hanging out a little bit more. Hard to say exactly. So I could take these extra pieces and combine them up to make at least one more full square and a little bit more extra. Okay, but you need to just be able to figure out and explain why that would be with some words. Here's the picture, the next one, of 2 squares and a circle. We want to explain why the area is more than 18 and less than 36. Same idea once again. Why is it somewhere between it's going to be greater than 18 and less than 36? All right. So again, looking at the picture, once again, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 shapes already right there. That's already 12 squares. I have these halves that combine to make whole ones. So here's 12. This becomes 13 when I put those together. 14, and then I have a 15, a 16. Here's 17, and here's 18. So when I just put the triangles together, I'm already at 18, but I still have all this space up here to go, don't I? Okay, so if I look at my extra triangles, I can kind of think about this as being here's 19 together, here's 20, over here it could be 21, 22, 23, and 24. So I'm about 24 so far, and I still have all these extra ones here to go. So I have all these guys to go, and all those guys together, well, even if I had them all being whole, 1, 2, 3, 4, 5, 6, 7, 8, 24 plus 8 would be 32. That's still less than 36, right? So I'm somewhere in the middle between 18 and 36 for the number of squares it would take to fully cover this shaded area there. Okay? So that's kind of how I would look at that one there. For number 3, it says circle A has an area of 500 inches, and this comes off the summary we did together, okay? It says that diameter B is 3 times the diameter of A, and then estimate the circle of A. So, circle B, area of circle B. So what we're looking at here is that I have a diameter, and area chart like so. Okay? We know that for here's A and here's B. Okay? And if A is, for example, 1, B has a diameter that's 3 times more than that, right? So going down this way, it's times 3. A had an area of 500. Well, to move from 500 of A down to B, I don't just multiply by 3, I multiply by 3 squared to get this value. So 3 squared is actually equal to 9. And so I will do 9 times 500, and that would equal 4,500. So the area of B, because it has a diameter 3 times the size of A, would be 4,500. Okay? This again comes off with a summary, the chart we made here at the end of our lesson right there. So by using this, that's how you really get that answer there. So if you didn't make that chart, it does make it a little bit complicated to figure that out, unless you just kind of got it from the lesson, which you might have, which is great. Next one, number 4. Lynn's bike travels 100 meters when her wheels rotate 55 times. All right, what is the circumference? So what are we saying? That she goes a distance, whatever that distance might be, and that distance is found by taking her circumference times the number of rotations. Alright, so we can call this the distance is going to equal, in this case here, we would say We're just going to find circumference, so we can leave it like that. Because the question is, what's the circumference? I was starting to work too hard there. I was starting to find out the diameter. Don't need that. So the distance in this case here is 100 meters. We want to find out what the circumference is going to be when she rotates 55 times. Okay? That's what we're looking for there. So 100 equals c times 55. We divide both sides by 55 to tell us that 1.81 is going to be equal to our circumference. Okay, so that's the idea behind that one. Let me double check real quick. Yep, 1.81. My notes got a little messy. Could you find the diameter from that, right? That's a good question. That's going to be like on a test coming up at some point. Could you find the diameter if you knew that? I would hope you could. To find the diameter, if you know the circumference, that would be 1.81 is equal to pi times the diameter. If you divide both things by pi, 3.14, that should give you the diameter, which in this case would be 0.579 equals the diameter. The question you should ask yourself is, if you know that, can you tell me what the radius is going to be? I hope so. Divide that by 2 and you get 0.289. Alright, that's just some extra playing with numbers, but something you need to be able to do as we work through this unit, okay? Number 5, find the circumference of this circle. Alright, well, circumference is going to be equal to pi times the diameter, right? Pi times diameter. The pi is still going to be the same, 3.14, and our diameter happens to be, the length there, 15. 15 times pi is equal to 47.1, and this would be centimeters. Alright, and our next one here, it says that Priya drew a circle whose circumference is 25 centimeters. Claire drew a circle whose diameter is 3 times the diameter of Priya's circle. What is the circumference of Claire's circle? Remember, that diameter is proportional to circumference. Okay? This means don't work too hard here. It's what that means. Alright? So what we're going to do is we look at the diameter. The diameter in this case here, right, diameter of the first one, because we're going to be going 3 times larger, then all we have to do is take the circumference of the first one, multiply it by 3, because it's going to grow 3 times the same, and we end up with 75. It's proportional. Okay? We take the circumference of one, and to find the circumference of the other, because it's proportional, it's going to be, it tells us 3 times larger, and we're done. And that's all there is to do for that one. Okay? Alright, good luck on anything else you got going on. Have a great day.